Right, boys and girls, good evening, good morning, good afternoon. It's time for OSPF Advanced Lab. So let's work on it. Let's go ahead and start doing some troubleshooting here. We need to start configuring, in fact, some of the routers. So let's read a little bit about this topology. Or let's try to understand it. We have a total of 3 routers and 2 layer 3 switches. We have to connect all of them with the different areas, OSPF areas, and full connectivity between all devices. So this is basically the idea. This is what we are going to do. There are a total of 3 areas: area 0, the backbone, area 1, and area 2. Those are the areas. So let's go ahead and clear those nodes, and we can start working alone and figure this one out. First thing we do, if you guys remember, we're going to copy the whole configuration of switch 1, but we need to remove the spaces. So let me go ahead and work on that. Let's just remove those spaces. It will take a couple of minutes or seconds, and hopefully we will be able to do so. Let me just copy and go to router 1 and paste it there. I do enable, configure terminal, and paste it. Let's do an end and a WR, and voila, we're done. It might take a couple of minutes or seconds so the interfaces come back up. And sometimes it depends on the other end of the topology. Let me check on something real quick. This one is on, this one is on. Looks like the interfaces are on. I don't know why we are not seeing the green color there. That's strange. That's pretty much strange. We have to do the not shoot, but apparently we already did. Let's do a show IP interface brief. It's showing down for some reason. Let's go ahead and configure the other end. Maybe we need to configure the other devices to have full connectivity. So let's work on router 2. Copy and paste that configuration. Let's go ahead and increase the size a little bit. Okay, we need to slowly copy and paste it there and remove all spaces. So let's work on that. Let's remove all those spaces. It will take a moment. Let me just copy and paste it. Let's go to router 2 and I will be doing an enable, config T, and paste it there. Right now we can see some of the interfaces are coming in green color. Great. Next thing, same thing, we have to work alone on configure, on this case, router 3. Remove all spaces, one step at a time, just one step at a time. Let's just remove all those. Let me go ahead and copy the information from router 3 and paste it there. Let me do an enable, config T, and then let's go ahead and paste it there. Amazing. Let's do an N and a WR, and the configuration is fully saved. Now we have to configure the layer 3, D1, which is the first layer 3 switch. It means that it has capabilities of routing. When a switch is a layer 3 device, it can do routing. So we're going to work in that in a moment. The first thing we do, we just close those windows and we go to D1. Now, do you see the error that I keep getting when I try to access the CLI? What do you think is going on? What happens is that this switch doesn't have a power supply. We need to integrate it. So let me just add it to the device. It will take a couple of seconds. Let's do that with D2 as well. So let's add power supply. Let's just leave it there. And let's be patient because it will be popping up with all the interfaces functional in a moment. Let's do a node there in the first switch. Let's do a node in the second switch in the CLI. And there you go. First thing we do, we already have that configuration for D1, so let's just copy and paste it here. Let's do an enable, then a configure terminal, and let's paste it there. Let's do an N and a WR, and there you go. Now, next thing we do, we go to D2. Let's go to D2, and we can start adding those configurations. Enable config T. First thing we do, we need to get that configuration and copy this information in a notepad. Okay, let me just remove alt spaces for a moment. It will take a couple of seconds. And we're going to do the following. We're going to copy this information and add it in D2. So let me paste it there. Great. Let's go ahead and validate two of these devices. We are not going to validate all of them. Let's validate router 1 per se. Let's validate router 1 and the switch. There you go. It is up and up. And switch 2, D2. Let's validate switch D2, which is a layer 3 device and is up, up, meaning the interfaces are successfully configured. You can do in the next couple of routers executing the same command. We will be getting the same result. Basically, everything is up, up. We are getting full connectivity. Okay, next thing we do. Next thing we do, let's see, is a ping test in router 1. So let's go to router 1 and let's do this connectivity ping test. It will take a couple of seconds. Eventually, we will get at least a 60% for this connectivity, hopefully. It looks like we are losing some packages. Oh, maybe, just maybe the computer is not correctly configured. We might have to add the configuration to the computers. So let's work on that. Let me go ahead and work on the configurations for those computers, PC1 and PC2. Let's go ahead and validate that. Do they have an IP address? I thought I already configured that, but yeah, they have it. So we're missing something else. Maybe I didn't add the correct IP address when I was doing the ping test. Let me validate that real quick. We need to do a ping test from router 1 to a specific device. What is it? Um, it is one of the neighbor's devices, and I actually added the incorrect IP. Is No, it is the right one. You see, it is 10.10.0.2. Where is that IP address? Maybe we didn't configure it correctly yet. Let me take a look. 10.0.0.2. It should be right here. Let's validate that. Oh, I know what is happening. Um, the switch is having a physical problem. We need to change this cable. Let's erase it and let's configure it in another cable. So from gigabit 001, it will go to gigabit 001. It will go to 1011. And now we have to configure that IP address there. And it will be, yeah, let's do a ping test here. Okay, nice. That was the problem. Let's just save this for now. And let's continue working with the router 1. Let's run that ping test one more time. And there you go, 100%. Next thing you do is we have to do a ping to 172.16.0.2. Let's do a ping test here. It will probably fail. It actually works successfully with no errors, 80%. So we're done with this section. Next thing we do is we need to configure IP routing on D1. So let me do a WR here and let's go to that device. D1. Okay, let's try to access it. And let's do it. Let's do it. IP routing. Okay, let's do router OSPF123. router ID 1.1.1.2, autocalls reference bandwidth 1000, and that's pretty much. What else are we doing here, guys, boys and girls? We have to do a net to 10.10.0.0. That is one of the connected networks, directly connected networks. This is in area 1. Be careful with the areas. Same command, but now we are going to do the 10.10.1.0, and the mask will be 255 at the end, if I'm not mistaken. There you go. WR, we save the configurations, we do a 2IP protocols, and there you go. You have the areas, you have the connectivity, the router ID, the administrative distance, and the process for OSPF. Next thing, show IP OSPF interface brief, and there you have it. Right now we can see one is waiting and the one is as the DR interface. So it will take a moment to finally have the connectivity fully um, converge. And we still have to configure D2, so maybe that is one of the reasons because it's not working completely. Let's go with router 1 and let's start adding this configuration. Let me just copy this script and then change some things here. Let me just remove all these. We have to do a config T in router 1, so let's do a config T and paste it. There you go. Next thing we do, we add the first network, one of the first networks, and paste it there. We add the second one. One is in area 0 and the other one is in area 1. And finally, let's do an end. You can see it is full, from loading to full. The OSPF connectivity between neighbors has been successfully and effectively applied. We see the adjacency was formed correctly. So let's do a show IP protocols there. And there you have it. The process ID, the different networks, the gateways, the administrative distance, the router ID. We are pretty much done. What else are we missing here? This one is pretty much similar to IPOSPF, but instead of that one, let's do a database. Let's do the same one. Let's just copy and paste it, and let's do a database. You can see it's pretty much similar. I'm trying to get the same as this one, but I don't see it. Show IP OSPF. Let's see which options we have for OSPF. Okay, interface. Show IP OSPF interface, and you can see it's pretty much the same information. Very similar. Nice, nice. Which other options do we have here instead of interface? Which ones? We have database, we have neighbors, we have border routers. Let's do border routers. It doesn't really show information because we don't have any border routers. Let's go ahead and do a IP OSPF interface brief to see which data comes up. And you can see some of the neighbors are finally the DR and the PDR successfully completed. IP OSPF neighbors, pretty much the same. Let's do a copy and paste there. There you have it. Full DR, full designated router. Let's run this other IP route command just to see if we collect more information. Nice. You can see the IP address is coming from 1.1.1.2, is getting via gigabit 001, is a type of intra area, administrative distance, the process ID for OSPF, and the routing entry for this specific network. What else are we missing? Let's try this gateway command to see if it works. If not, we will figure something out. It didn't work, but let's do, instead of that one, let's just do try route OSPF, and you can see it is currently successful. You can see the output. Let's go ahead and configure router 2. Let me just copy this configuration and do some magic here in that notepad. So we can just copy and paste this stuff. This is the basic script for adding and integrating OSPF. Are we missing something? Yes. Let me just add this at once for router 2. Let's just remove those characters. We don't need them. Let me also add the default information originate so we can propagate that default route to the internet. So let's do that. Let me just copy and paste it there. Are we missing something, guys? Boys and girls? There is another IP route to get to the loopback and get to the internet. So let me add that as well. Let me just copy that and paste it there. We need to do a config T and all that, but remember, we're in router 1. We need to move to router 2. So be careful. Be careful about that. You are accessing the correct device, the correct router, before adding that configuration. Config terminal, and let's paste it there. There you go. Easy peasy. Show protocols is the next command that we're going to execute. And there you have it. Control A, and let's do a 2. And there you have it. You have the networks, the areas, the gateways, the process ID, and the router ID. Next thing we do, show IP OSPF interface, followed by, remember the do. The do is important here because we are in configuration privilege mode, and that's what we need to do. Let's do an end and a WR, so we keep saving these configurations that we just did. Show IP OSPF neighbors is the next one. Are we missing something here? Neighbor detail will give us a little bit of more information. Show IP OSPF neighbor detail. That's another important command. State is full. Okay, what about show IP route OSPF? Do you guys think we will get the info? Of course we do. And finally, what are we missing here? Show IP route static. Let's see if there are static routes in this. And there is one actually connected to the loopback. Okay, let me just copy this for now. We have to configure router 3. So let me just copy this here and the rest. And I will work on removing those characters that we no longer need or require here. So let's work on that. Control Z if you make an error like that. Okay, just be careful. Let's just do this. Let's just have it there. Okay, great. Let me copy this information and paste it there. Let's do a config T. And let's just paste it there. Great. Clear OSPF process. So this will take place. We are not going to do it. Well, let's do it. Let me see which options we have for this. Usually there is an asterisk, so we can make it like a soft. Yeah, let's just clear the processes for now. Let's do a show IP protocol and see if we can see more information here. And let's do a WR so we save it. Oh, we are doing something wrong here. We configure router 2 and router 3 as the same. Let me just clear that. Config T. Config T. No router OSPF. 1, 2, 3. Let me go ahead and return to the previous configuration that we had before for router 2 and copy and paste this configuration. And let's validate something with the show run command because I was having a problem there. I was adding the incorrect information. Default information originate. Do we need that one for router 2? Yes, we need that one. Yeah. Okay, so you saw what happened. I pasted incorrectly the configuration of router 3. I was so focused in adding the configuration, I didn't realize I have to even delete the process. So let's validate the router 2 configuration real quick that we have before. We have the router ID, we have the process, we have the networks. Everything looks good. Yeah, pretty much the same. Yeah, we have to be careful. Let's do a WR so we save the configuration. And now we can finally go to configure router 3. Let me just look it up. Where is it? Do you guys see it? The configuration for this? Yeah, it is right here. So let me just copy and paste it there. We need to remove all these unnecessary spaces or these characters. Let's remove this. And what we're going to do is basically carefully, so we don't mess up, we go to router 3 and add this configuration. So let me just copy this, go to router 3, and let's do a config T, config space T, and then just paste it there. Let's do a WR, and let's validate that we can do a ping test from one end to the other one. If not, we might be having some issues there. And sometimes it takes time. Remember, OSPF might be slow. So let's do a test one more time. Looks like we finally have it. Let's do another ping test from this router 3 to this one. And looks like we have it. Do you guys see there might be a problem? Are we missing something? Yes, of course. We need to configure it still. Um, let's do a try POSPF neighbor to see the neighbor that we currently have here for this device. It's actually two neighbors in total. One is the full DR and the other one, let's see if it is two or one. It's only one. It is only one. D2. D2 configuration is missing. We have to do a config T and we have to go and do an IP routing here. Routing. There you go. Now we need OSPF for D2. So let me go ahead and copy this. Now we have to remove the spaces. Okay, almost done. We're missing this other part. Let me just copy and paste it there. Let's remove it. Let's go ahead and remove this. What are we missing, boys and girls? What are we missing? Let me just copy and paste it there. I think we're pretty much done with this lab. Let me do a try OSPF neighbors. You might be able to see them very, very soon. It is start. Remember the start. Before that, we have the um loading and then the full. Nice, nice. We are remembering some of the different process to form a NOSPF neighbor adjacency. Show IP OSPF protocol. Let's do that one. In D2. Nice. You can see the process ID, the areas. One is the BDR and the other one is waiting. Now we have a DR and a BDR. Show IP route OSPF is the next command we will execute. Let me just clear that for now and paste it there. Nice. Great job. We can see there is actually a total of 4 different interior areas. Indeed, too. Interesting. Now we do an IP config to validate student. So let me go to that PC and run that command. You can see the IP address for this one is 10.10.1.10. Let's do a ping test to the other PC to see if we can fully connect to that one. We have a ping connectivity. Will it work or will not work? What do you guys think? We got a timeout on the first one, but the other one they successfully work with no issues. Let's do the ping one more time just to cover our backs. And voila, this working successfully. Let's do a tracer. Remember, the ping was to test connectivity between one end to the other, and the tracer is all the jumps, hops, I mean, all the hops, one hop to the other, until we finally reach from the origin to the destination, from the source to the destination. What else are we missing? We have type 2, type 1, type 3. There is a summary, an explanation, so we can go over those. If you do a 2IP OSPF neighbors, you can see the neighbors here in D2. It is not neighbors, but neighbor. You can see the neighbor. 2IP routes. Let's do it's pretty much the same. Let's do this in D1 because it's talking about D1. So let's do it in D1 as well. Let's go ahead and place it there. Let's do a 2IP OSPF neighbor. And there is actually two in total. It's actually one. It's one for this D1 switch with layer 3 capabilities. 2IP OSPF database will show us more information regarding the databases. So let's just paste it there, and there you go. All the databases information is popping up right now. Okay, what else? What else? Try OSPF database. Try OSPF database network. Let's see if this one works. Yeah, you can see some information related to the area 1 and process ID and the router ID for OSPF, the link state, the advertising router, the mask. Nice. That is actually a different mask. It's not the decimal, but um it's not the binary, but it's a decimal format. So we're talking about a decimal cider notation format in this scenario or this case. Let's go ahead and run this other command in a router. It's actually D1. This is layer 3 switch. And we are missing something. What do you guys think we're missing? It is show IP OSPF database ASBR summary, and you can see the ASBR routing. So basically, you can see some information with this one, but this output lists type 4 LSA advertisement by R1, identifying 2.2.2.1 as an ASBR. The next one is for external information, so let's execute this one. And there is some information there. This output list type 5 LSAs identifying 0.0.0.0.0 available from 2.2.2.1. Okay, then we just do a 2IP OSPF database in router 1. Let's do it. Let's do it. Okay, let me paste it there. And there you have it. You can see all the information regarding the database for this specific router. Next thing we do, we have to do a 2IP OSPF database one more time. Paste it there. And then I think we're pretty much done. Let's explain this last command. And this is what we have. This is actually router 1, router 2. So let's go to router 2. Let's go to router 2 so we can copy and paste it there. What do you guys think we have in this scenario? Okay, so this output display type 1, 2, 3, and 5 LSAs in area 0. Notice that there is no type type 4 LSA because router 2 is an ASBR and only an ABR can generate LSA 4. So let's see what we have here. Type 5. We have some type 3 here, the summary network link state. Type 2, the network link state. And the router link state, this is actually type 1, this case or scenario. I think we're pretty much done with this lab. We have completed all the troubleshooting steps, all the testing. Let me just save this configuration. And let's do a final test one last time. I think we already did it, but let's do sending an envelope from one side to the other one, and you can see the successful connection in this topology network. I think that's pretty much. So it's been a pleasure, boys and girls. I will see you at the top of success. Until next class, goodbye.